Hello everyone, welcome you all once again to this online session. Last week I had started with this chapter, that is chapter number 5, periodic classification of elements, and in that we had learnt why was this way of arranging the elements brought into use, what was the need for forming a periodic table, and about the scientists who had worked towards the arrangement of elements. And then we had learned about Daubernier's triads, Newland's law of octaves, Mendel's periodic table, and we also learnt the reasons for not practicing their way of arranging the elements. First, let's have a quick recap of what we had done in the previous session, and then I'll start with today's session. So first, what's the meaning of a triad? A set of 3 elements. Daubernier in sets of 3 means every group had a set of 3 elements, and he had put them in the increasing order of the atomic masses, and he found that the atomic mass of the middle element was equivalent to the mean atomic mass of the first and the third element. This was not accepted because he could not complete his way of arranging the elements existing during his time by obeying this law of triads, and certain groups did not obey his rule, so it was not brought into use. Then we saw about Newland's law of octaves. So in that we saw that when Newland started arranging the elements in the increasing order of their atomic masses, he found that the property of the 8th element was similar to the property of the first element, and after calcium the elements that were existing did not obey his rule, so even that was not brought into use. And he had also placed two elements in one box, and he did not put the elements according to their nature in proper order. So these are the reasons for not bringing his way of arranging the elements into use. And then we had discussed about Mendeleev. So he was the first person to arrange all the elements that were existing during his time in his periodic table, and we saw about his merits and demerits also of the periodic table, and I told you that it is a very important question. So what about the merits of Mendeleev's periodic table? He was the first one to put up all the existing elements in his periodic table, and he had left some vacant places, and he was the one to come out with the concept of groups and periods. And later on, when inert gases were discovered, they could be given separate position without disturbing the existing periodic table. These were the merits we had seen. And as far as demerits were concerned, he did not give proper explanation for placing hydrogen in the first group in spite of it being gaseous in nature. Then when he had spoken about the elements are arranged in the increasing order of their atomic masses, and he did not think about the existence of isotopes, because isotopes are atoms of same element having same atomic number but different atomic mass number. In that case he should have left more vacant places, so he did not speak about that. And then he said that he had arranged the elements in the increasing order of their atomic masses, and in that case he could have placed cobalt and nickel in proper order. It should be nickel and then cobalt, but he had placed cobalt first and nickel after that. So proper explanation was not given for all these things, so it was not brought into use. At present we are using modern periodic table. So in today's session we will be learning about the modern periodic table, how was it framed, what are its characteristics, how are the elements arranged in it, and then about valency, and about atomic size, metallic and non-metallic properties. These things will be covering up today, and with that this lesson will come to an end. Okay, and at the end of this session I have given an assignment, so it's compulsory for all of you to complete that and bring it when you come to school. So we'll quickly get into the session. So we'll start with modern periodic table. In 1913, Henry Moseley showed that the atomic number of an element is a fundamental property than its atomic mass. So Mendel's periodic law was modified and atomic number was adopted as the basis of modern periodic table. Mendel's periodic law states that the physical and chemical properties of elements are periodic function of their atomic masses. Since in the modern periodic table, while arranging the elements, this Henry Moseley considered the atomic number to be the fundamental property of the elements. the modern periodic law goes like this: the physical and chemical properties of elements or the periodic function of their atomic numbers. Therefore, in modern periodic table, the elements are arranged in the increasing order of their atomic numbers. Let's have a look at the modern periodic table, then I'll tell you how the elements are arranged there. See, this is your modern periodic table. So here in the modern periodic table, the elements are arranged in the increasing order of their atomic numbers. See, the first element here is hydrogen. Second element towards the extreme right, it is helium. Then you have lithium, then you have beryllium, boron, carbon. It goes on like that. So when you look at the numbers which are mentioned above the chemical symbols of these elements, that is above H, above He, above Li, you will find these numbers. Above H it is 1, above He it is 2, above Li it is 3, above B it is 4. So those numbers are nothing but the atomic numbers. Therefore, in the modern periodic table, the elements are arranged in the increasing order of their atomic numbers. So in the modern periodic table also, we have this concept of periods and groups as framed by Mendeleev, because it was said Mendeleev's periodic table formed the basis for the modern periodic table. So in this also, this way of putting the elements under proper groups and in proper periods were adopted. So in the modern periodic table, we have 7 periods and 18 groups, and it has got 4 blocks: S, P, D and F. So in the upcoming slides, we will learn how the elements are placed under proper groups, what rule is adopted when elements are put under one particular group, what rule is adopted when the elements are coming under one period, and how are the elements arranged in the modern periodic table. Where do you find metals, where do you find non-metals, where do you find metalloids, under which group you find them. This is what you will be learning today. Okay, so let's now learn about position of elements in modern periodic table. I said Mendeleev was the first person to come out with the concept of putting the elements under a particular group and periods. So he had introduced the concept of periods and groups. So Mendeleev's periodic table formed the base for the modern periodic table. So modern periodic table also has periods and groups. We all know that the vertical columns are called as groups and the horizontal rows are called as periods. So modern periodic table has 18 groups and 7 periods. So now see, when the elements are put under a particular group or arranged in a particular period, they have some relevance amongst them. So let's learn how that is done here. See, I said modern periodic table has 7 periods, and whatever is a period number, the period number tells you the number of shells around that element. So if the period number is 1, the elements coming under period number 1 are hydrogen and helium. So they will have only one shell around them. Now when we take up the elements in period number 2, that is your lithium, beryllium, boron, carbon, nitrogen, oxygen, etc., they will have 2 shells around them. So elements under period number 3 will have 3 shells around them. So whatever is the period number, those many number of shells will be found around the elements belonging to that particular period. Okay, let's take the example of elements coming under period number 1. I said hydrogen and helium. Atomic number of hydrogen is 1. Atomic number of helium is 2. Therefore, number of electrons possessed by hydrogen is also 1 and by helium atom is also 2. So atomic number states you the number of electrons. So you also have learnt the distribution of electrons. First shell has the capacity to hold 2 electrons, second shell onwards 8 electrons, third 18, it goes on like that. So hydrogen atomic number is 1, so it will have only 1 electron and it will have 1 shell around it. Helium atomic number is 2, 2 electrons is the capacity of the first shell, therefore it will also have only one shell around it. So they are all coming under period number 1, that is this hydrogen and helium. So they will have one shell around them. Now second period consists of elements like lithium, beryllium, boron, carbon, nitrogen, all those things. So when we look at their atomic numbers, lithium has atomic number 3, therefore its electronic configuration is 2 and 1, right? So it will have 2 shells around it. Now beryllium atomic number is 4, its electronic configuration is 2, 2, therefore it will also have 2 shells around it. Then boron atomic number is 5, so electronic configuration is 2, 3. First shell has the capacity to hold only 2 electrons, second shell has the capacity to hold 8 electrons, but atomic number is 5 means there are only 5 electrons. So 2 electrons will be in the first shell, remaining 3 electrons will be there in the second shell. When we talk about carbon, atomic number is 6, electronic configuration is 2, 4, therefore first shell will have 2 electrons, remaining 4 electrons will be found in the second shell. So these elements like your lithium, beryllium, boron, carbon, nitrogen, they are all falling in this second period, therefore they will have 2 shells around them. So whatever is the period number, that indicates the number of shells around the elements. If it is period number 3, they will have 3 shells around it. Understood? Now depending on the number of elements possessed by every period, they are classified as short period, long period, longest period and all. So the shortest period will be the first period because it has got only 2 elements, hydrogen and helium. Second and third period has 8 elements. Your fourth and fifth period will have 18 elements, and sixth period is longest period with 32 elements in it. Okay, so this is all about periods. Periods are nothing but the horizontal rows. So whatever is the period number, the elements coming under that period will have those many number of shells around them. Okay, so as you go down the periodic table, the shell number will start increasing. That means they all belong to different periods. Okay, elements falling under one group will belong to different periods. That we will learn when we are talking about groups. Next, let's talk about how the elements are arranged in the group, what are their characteristics, based on what basis they are put under particular group. So I said modern periodic table has got 18 groups. Okay, group number 1 consists of alkali metals, like all your first group elements. When you consider, you will have these elements: hydrogen, lithium, sodium, potassium. They are all coming under group number 1. So the specialty is that they will have only one electron in its outermost shell. So the group number represents the valence electron present in the outermost shell of the element. Understood or not? Let me give you example. I'll take the example whatever is mentioned on this slide now. See here, when you take these elements like your fluorine and chlorine, look at them, they all belong to group number 17. Okay, fluorine atomic number is 9, so electronic configuration is 2, 7. Chlorine atomic number is 17, therefore the electronic configuration will be 2, 8, 7. Fluorine has got 2 shells, chlorine has got 3 shells around it. So the outermost shell of fluorine, that is the second shell, consists of 7 electrons. The outermost shell of chlorine, that is the third shell, also has 7 electrons. So the number of electrons present in the outermost shell of these elements remain the same. So they are said to be falling under one group. Okay, so valency talks about the number of electrons that is to be gained or lost while a chemical reaction takes place. So the number of electrons a particular element is going to lose or gain. Okay, so valency normally increases from 1 to 4 and then it decreases from 4 to 0 as you move towards your right side of your periodic table. That we will do little later. Now talking about this groups, the speciality is that elements falling under one particular group will have same chemical properties and they will have same number of valence electrons in their outermost shell. Okay, and their shell number will keep increasing because you are coming down the group, no, you are coming down. When you are coming down, the period number changes. Therefore, the number of shells will keep increasing, but the number of valence electron in the outermost shell will remain the same. For that only I have given this example of these group number 17 elements. Your fluorine and chlorine, bromine and all these things, you see, they all belong to 17th group. But when you look at their electronic configuration, you will find 777 electrons in their outermost shell. They are called, means the number of valence electron present in the outermost shell of these elements remain the same. Let's take for example group number 1, few elements we will take, whatever is known to you. I will take the example of hydrogen, lithium, sodium, potassium. Okay, hydrogen atomic number is 1, so it will have 1 electron and 1 shell around it. Lithium, it belongs to second period, atomic number is 3, so 2 shells will be there. First shell will have 2 electrons, remaining 1 electron will be found in the second shell. So see, second shell is having only 1 electron. Hydrogen, its outermost shell is having 1 electron. Now let's come to sodium. Atomic number is 11, so electronic configuration is 281, so 3 shells, last shell is having 1 electron. Let's talk about potassium. Its atomic number is 19, right? So when you write the electronic configuration of this, again 2881, right? So again 1 electron in the fourth shell, outermost shell. Okay, so the shell number keeps increasing, but the valence electron found in the outermost shell of the element remain the same. Okay, hope it is clear to you. And one more thing you should remember, group number 17 are said to be halogens except one element, astatine. Okay, and group number 18 is called as your noble gases or inert gases or zero group elements because their valency is 0. They have complete outermost shell. All your elements like helium, argon, neon, krypton, xenon, they all come under group number 18. Their outermost shells are totally completed. They do not take part in any chemical reaction. Their valency is said to be 0. They do not have any electrons to lose or gain. They already have it packed. So their valency is said to be 0. Hope it's clear. In modern periodic table, the elements are divided into 4 blocks, that is S block, P block, D block and F block. Elements belonging to group number 1 and 2 come under S block. Elements belonging to group number 13 to 18 come under P block. Similarly, elements belonging to group number 3 to group number 12 come under D block. Okay, and at the bottom of the periodic table you will find 2 sets of elements with atomic number 58 to 71 and atomic number 90 to 103 placed separately. They are categorized as F block elements and they are called as lanthanide and actinide series and they are called as inner transition elements. I will tell you why, why is it placed down separately. Okay. Now, I said S block elements consist of elements falling under group number 1 and 2, they are all metals. P block consists of elements belonging to group number 13 to 18 and it is a combination of metals, non-metals and metalloids. And similarly, there is D block elements which comes under the group number 3 to 12, they are also metals. See now, at the bottom of the periodic table you find these inner transition elements and they are all coming under F block and they all belong to group number 3 and your lanthanide series belong to period number 6 and your actinide series belong to period number 7, but they both belong to same group. Okay. Now, when you look into your modern periodic table, at the place of 57th element, when you look at the atomic number, they must have written 57 to 71. 57th element will be seen there. 57th element is your lanthanum with the symbol La. They must have written La to Lu. So, La will be found there and its atomic number is 57 and your 71st element is your Lu, that is your lutetium. So, from the element having atomic number 58 to atomic number 71 will be found under this F block, and they belong to lanthanide series because they resemble properties close to that of the element having atomic number 57, that is your lanthanum. So lanthanum is La and your lutetium is Lu. So La to Lu they must have written there. So 57th element will be seen there in P block, whereas your 58th element will be seen under your F block. Similarly, 89th element is your actinium Ac, that will be seen under P block there. From 90th element, that is your thorium, will be seen under F block till your lawrencium, that is element with atomic number 103 and with symbol Lr. If you look into your book, it will be more clear to you. I will given that series separately here. So these actinide series elements also resemble their properties close to that of that element called as actinium with atomic number 89. Okay, but these lanthanides and actinides, they belong to the same group called as third group. Okay, and their period number is different. Lanthanides belong to period number 6 and actinides belong to period number 7. Next, let's talk about the merits of modern periodic table over Mendel's periodic table, or in other words we can say how where the anomalies regarding Mendel's periodic table was overcome in modern periodic table. First, it was said Mendeleev had not spoken about isotopes. When he had arranged the elements in the increasing order of their atomic masses, he should have given separate place for their isotopes, because isotopes are atoms of same elements having same atomic number but different atomic mass numbers. So he should have given separate place, but it is overcome in modern periodic table because in modern periodic table the elements are arranged in the increasing order of their atomic numbers. So isotopes are atoms of elements having same atomic number and different atomic mass number, so they need not be given separate position. Next, they said Mendeleev did not place this cobalt and nickel properly because his table he had arranged the element in the increasing order of their atomic masses. So in that case nickel should have come first and cobalt should have come after nickel, but that is also overcome in your modern periodic table, because modern periodic table the elements are arranged in the increasing order of their atomic numbers. Therefore cobalt is having atomic number 27 and nickel is having atomic number 28. Therefore cobalt will come first and nickel will follow that. So the anomalies regarding Mendel's periodic table is also overcome in modern periodic table. Okay, can be defined in many ways. It can be called as the combining capacity of an element, or it can be called as the valency is the number of electrons gained or lost when elements take part in a chemical reaction. So the valency of an element is determined by the number of valence electrons present in the outermost shell of an atom. This we had discussed when we were talking about groups. Elements belonging to a particular group will have same number of valence electrons. I told you elements coming under group number 1 will have only one electron in its outermost shell, therefore its valency is 1. If the elements are having 2 electrons in their outermost shell, they come under group number 2 and their valency will be 2. But this valency increases from 1 to 4 for the second and third period, and then it decreases from 4 to 0 as you go towards the right of your modern periodic table. For example, let's take this group 17 and group 18 elements. Group 17, I told you that chlorine, fluorine and all, they have 7 electrons in their outermost shell. So they need 1 electron to complete their octet. So 1 becomes their valency. When you talk about 18 group element, they have complete outermost shell. So they are called as 0 group elements. They do not lose or gain electrons. So their valency will be 0. So valency increases from 1 to 4 for the second and third period, and then it decreases from 4 to 0 when you go from left to right in the table. I have given an example of the elements belonging to period number 3 to show the valency, how it increases and decreases. See, I have given the examples of elements belonging to period number 3, that is your sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Here the atomic number of sodium is 11, its electronic configuration is 281, valency is 1. Magnesium atomic number is 12, its electronic configuration is 282. So valency is the number of valence electrons present in the outermost shell of an atom of the element. So 2 becomes its valency. Aluminium electronic configuration is 283, 3 becomes its valency. So now when you go towards that, you see this chlorine, I told you now 17, 287, it wants 1 electron to form its octet. So 1 becomes its valency. When you talk about argon, atomic number is 18, so electronic configuration is 288. So whenever a shell has, from the second shell, if it has got 8 electrons in its outermost shell, it is said to be a complete shell. So its third shell is having 8 electrons, so it forms a complete octet. It will not take part in chemical reaction because it will not gain or lose electrons. Clear? Next, let's talk about atomic size. Okay, the term atomic size refers to the radius of an atom. You must have learnt in your geometry. How will you draw a circle? By taking the radius. What is radius? It's the distance between the center to the circumference of the circle. Similarly, the atomic size may be visualized or can be defined as the distance between the center of the nucleus and the outermost shell of an isolated atom. So this atomic size will not be the same. Elements belonging to a particular group, their atomic size will keep increasing, because elements falling under one particular group belong to different periods. When they are belonging to different periods, their shell number will keep increasing. When the shell number increases, the distance between the nucleus and the outermost shell also increases. So down the group, atomic size increases, and across a period, the atomic radius decreases, because when moving from left to right along a period, there is an increase in nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom. This we have learnt. Elements belonging to a particular period will have same number of shells, but the number of electrons in the outermost shell need not be the same. So that concept of nuclear attraction will keep increasing. So when it is tending to pull it towards the nucleus, what happens? The atomic size will decrease. So across a period, atomic size decreases, and down the group, atomic size increases. Let's now talk about metallic and non-metallic properties. Before I get into this, I want you to know about the position of metalloids, where they are placed in the modern periodic table. Okay, we had learned while we were talking about these S block, P block and all. I said elements falling under S block are all metals. P block is a combination of metals, non-metals as well as metalloids. When you look into your modern periodic table, you will see a zigzag line in that periodic table. That line separates metals from non-metals. So those borderline elements are said to be metalloids. So the elements like boron, silicon, germanium, arsenic, antimony, tellurium and polonium are all metalloids. They are semi-metals. They possess the properties of both metals and non-metals. Okay, so the elements that tend to lose electrons are categorized as metals, and they are electropositive by nature. And we had learned that when we were doing this atomic size and radius, across a period the atomic size decreases, and down the group it increases because of the nuclear charge. When you come down the period, number of shells keep increasing, therefore the attraction also reduces, because of which you said atomic radius also increases. Similarly, metallic character across a period decreases, and down the group it increases. Now non-metals are said to be electronegative because they tend to accept electrons. Okay, so they are placed at the top towards the right side of your periodic table. Now when you are learning about acid, bases and salts, there is a separate chapter called metals and non-metals. In that you will learn the oxides formed by metals are basic by nature and non-metals are acidic by nature. That you will learn when we are doing that lesson in detail. So with that we are coming to an end now. So hope you are all clear. Now I want you to learn the merits of this modern periodic table, or how the anomalies of Mendel's periodic table was overcome in your modern periodic table, about the trends. They are all important. Valency, metallic and non-metallic properties, atomic size especially. Okay, these things should be very, very clear to you. And as I told you earlier, I have given an assignment. This is compulsory. You all will do this. I want you to do it in a tabular form. I want you to draw columns, and I want you to write the first 20 elements. You have to learn them thoroughly. It's very, very important. So you will learn the elements from atomic number 1 to 20. That is, you have to list the first 20 elements of the modern periodic table, and then you will draw columns. First you will have the name of the element, then you will have the nature, whether it is a metal or a non-metal, and then you will have its symbol, and then you will write its electronic configuration, and finally you will write its valency. So I want you to do this. You will all submit this when you resume back to your school. So with this I'm winding up. Hope you have understood it clearly. Thank you all. Stay blessed, and keep revising what is taught, and keep learning. Wish you all good luck. Meet you soon. Bye bye.